Okay, ladies and gentlemen, so I'm here with a lint bunny, some Jack Daniels, and some Frank Sinatra playing in the background, which you won't be able to hear the Frank Sinatra, but either way, I'm set here tonight to talk over the top of a video that I recorded a long, long time ago on how to create a four-way riser and floorway gully for hydraulics in Australia. I mean, Iplex, we're basing this off an Iplex product and it's an Australian brand. So we're starting off here with the riser of the four-way riser. And it's 110 mil external diameter. So what I've done there is I've created a circular extrusion and I've aligned and locked that to the front, back, and left, right reference planes in the reference level. Now what I'm doing is I'm creating a reference plane that will control the height, or I guess the depth, of the four-way riser itself. So for those that haven't created a parametric family before, the way that you control them is by drawing reference planes and reference lines, or sorry, reference planes or reference lines, dimensioning them, and then applying a parameter to that dimension. So you can see now, and of course you've got to align and lock all your 3D objects to the reference planes or reference lines. So you can see now I've changed that to 176 and that's adjusted our 3D object. So the next step, I'm going to create the connection points. So you can see there on the left hand side in our Iplex catalog, we've got 4 inlets to our four-way riser. So this particular one that I'm making is the 100 mil model or part number, which is the second one there in the list on the left. And it's got the single 50 inlet and 3 40 diameter inlets. So again, you create a circular extrusion and align and lock that, and we're lining and locking that to the left-right reference plane, which is that dashed one there that you can see, and then that solid line in the horizontal plane is the reference line that we drew. So I've realized actually that dimension, is in the wrong spot. I should have taken that from the bottom, so then that reflects what we're seeing in the catalog itself. Now, before I go too much further, it's a good thing to or a good point to make that you want to keep all your, I guess, drafting in a family consistent. So you want to have nice, neat dimensioning. You don't want everything to be cluttered. And you want to try and make sure that everything is in the same view if possible. So we do deviate from that a little bit later, but if you have the bulk of your dimensioning in the front view, then that makes a lot more sense than having to put things in the front and the left and the right and the rear view, because these dimensions only show up in the view that you place them in. So you don't want to have to go jumping around from view to view when you're trying to edit this family later on in life when it's an old grey crusty family and you've got to try and update it. So anyway, we've got our inlet there, and you can see there's our extrusion, and that extrusion comes off that front back reference plane. So now I'm popping in a few reference lines, and I'm going to set them so they're equal distance from that center reference plane. So the way you do that is the dimension in the way that I've just shown, and then you click the EQ button. The next thing that you do, you place another dimension, and that one will control the overall width that you're playing with. So what I'm going to do here, I'm actually going to reduce how far these inlet bits, for lack of a better technical term, protrude from the four-way riser itself. So I'm having them extend, I think I'll go for 6 millimeters beyond the 110 mil. So, so 2 times 6 is 12 on top of 110, so that's a total 122 that I'm going to go for. Now, yes, it does say 31 millimeters in the product catalog, but from many years of experience documenting hydraulic services in Revit, I've come to realize that having that 31 millimeter extension from the four-way riser means you can't really model objects as you would in real life, because in real life the pipe is going into a socket, whereas in Revit what it does is it just sort of attaches the pipe to the face. So that's why I pull that in. So it might not be 100% realistic, but it's far closer than, if you had that 31 mils. We're now on to creating our next connector. So we're going to do the 50 mil connector and the other 40 mil connector. And they're going to go both off the same reference plane in the center there and the same reference line, because they're both at the same height. Now, if you did want to make this parametric, to have the riser the inlet at a different height to the other, I'm just setting a parameter here, but it's actually not needed for this family. So these inlets from the different directions are all at the same height, which is 92 millimeters from the base there. So again, it's a circular extrusion. You turn on that center mark and you align and lock to the planes and to the line. And we set the radius. So going to be a little bit lazy there. Just use a formula. So equals 56 divided by 2. And, I don't have to use a calculator. It makes it really easy for me. And you can see there's our 50 diameter connections. Now we're going to do the 40. So this is going to be 43 diameter. So again, equals 43 divided by 2. And we'll align and lock this. And, the reason it's you got to remember it's 43 and 56 because that's actually the outside diameter of the pipe. So this is the socket that you would be slotting your regular piece of pipe into. So you can see there's our extrusions. And so now I want to set one so it comes off to the left on the screen and the other so it comes out to the right. So again, we're going to put these reference lines in to control our extrusions nice and neatly. And again, this is going to be set at 122. So it's a 6 millimeter extension. I'm going to align and lock these. So we've got the 50 millimeter there going to the the left hand side, and the 40 millimeter going to the right hand. And you can see that, well, you can't quite see that on the Iplex catalog at the moment, but that is how it goes together. So now you can see this is what we look like in plan. And I'm going to create the socket for the top of the four-way riser. Originally, when I first made this family, I didn't have this socket, but I actually had complaints from engineers. And they're like, this isn't realistic. I can't see the socket on the top of the four-way riser. Me, personally, look, I did design as well, and it didn't confuse me that it was a four-way riser, but anyway, got to keep everyone happy if you can. So socket goes on, and you can see there we've got this wacky extrusion. So we need to drag that down so it looks correct. So this actually isn't dimensioned in the catalog. So I'm going to base this off the socket size of one of the other fittings in the catalog. It looks right. It does look right, actually. It's going to hide these annoying reference lines. But you can see there's the basis of our four-way riser. We're pretty much done. So I'm just joining these pieces together so they have nice clean cuts on the model. And it looks like one shiny single piece. Look at that. It's amazing. All right, so I've overshot that diameter there. So I just need to shrink that down. So we're basically looking at external diameter plus the pipe thickness, the wall thickness. So the wall thickness is, I think from memory, it's 3 millimeters or so. So in all, this is going to be about 116 possibly. Can't quite remember. Recorded this a long time ago. But there you go. That looks far more accurate than it did like 10 seconds ago. So this is great. We're making progress. Okay, so now we've got that saved. one thing that I always forget is setting the family category correctly. So let's just set that to a pipe fitting because that's what this is. It's a pipe fitting. And I'm going to set it to shared as well. So what clicking that shared button does is when you have the overall floor waste, which we'll be working on in a minute, the way that this will work is that this family, this four-way riser that we've just made, will be nested into another family, which is our overall floor waste gully. And when you have the shared button ticked and you schedule everything in your model, that pipe fitting will come up so that you can cost your model properly if you want to go down to that much detail. So this time around, we're going to be working on the trap. Now, I'm basing this trap on that top one there that you can see, which is a 100mm disconnector trap. Now, this disconnector trap, sure, it doesn't say floor waste gully, but this is actually used in commercial situations. So for hydraulic designers out there would know that people stick weird things down drains. And the reason, well, one of the reasons why you want this 100mm drain or this 100mm trap is so things don't get blocked, and the plumber, if he needs to, can go out and he can stick his rod to clear out the line down the 100mm trap. So what I'm going to do is I'm going to put a reference line in here. Actually, I'm going a reference plane. Now, I'm putting this in to now start drawing our trap from. Now, our trap, well, I'm going to set the height first, obviously, so it's correct. So the trap is going to be a sweep. So a sweep is basically a shape that is, I guess the word would be traversed over a path. It follows a path. That sounds better. It follows a path to make a shape. So you can see there we're going to make the U part of this trap. So we start from our reference plane that we've drawn in, and we need that to be the depth of the socket. So the depth of that socket is 45 roughly. Now we're going to do a bit of quick maths in my head to figure out what the radius of this U is. So we're looking here, what have we got? We've got 110mm pipe diameter for external, half of that, 55 a pop, so that comes back to 110. But then we have that little itty bitty gap in the middle, so we'll give it a few millimeters on top. So 118 looks pretty good. So there's our U shape. And the next bit, we need to do that next socket. So you can see though that the next socket is a little bit lower, so I'm not going to go quite as far. Unfortunately, that's not dimensioned, so I'm just going to take a punt that's 40 millimeters. So it's probably not 5 millimeters shorter, but after a lot of testing, I've found that these images in the Iplex catalog aren't accurate. So you can't load them in and trace over them, basically, is what I'm saying. So this is our profile that we're going to extrude or sweep. And we finished, and there you go. Look at that. We have our U shape of our trap. So the next thing that I'm going to do is I'm going to put the sockets in for our trap. Again, we can't have poor old hydraulic designers complaining that our families aren't accurate enough. So again, just remember this is external diameter of the pipework plus the wall thickness times 2. So we're looking at a total of 116 here. We want to copy the extrusion across. You could do a new extrusion. Copy's as easier than making a new one. And you can see there we got two weird extrusions out the top of our reference plane, of our reference level reference plane. So I'm popping in a reference line here. That's going to be the top of our socket. And I'll just align and lock that to the top of our bend. And then again, we've got the depth of our socket, which we want to be fixed. And we're going to fix that in at 45. So now we align and lock our extrusions there to our reference lines. But don't align and lock the four-way riser. The four-way riser should already be aligned and locked to the ref level. So we'll just pull that back there a bit, and then we know what we're clicking on. So let's try that again. There we go, worked that time. Now we align and lock the top. And have a look at that. That looks pretty amazing. We have 3/4 of a floor waist. So we've got our four-way riser. We've got Frank Sinatra cranking in the background. And we've got our trap. So once again, I'm just going to join these objects together so they're all in one part. Or they look like they're one part. And then what we're going to get to now is we're going to create the last part of the trap, which is the outlet. Now, you might be thinking, well, Ryan, why have you made this floor waist as 3 separate parts? Well, that's the exciting bit for a hydraulics guy. But yeah, so that's the exciting bit. What we're doing is we're making this as 3 separate parts, so then we can rotate the four-way riser and the outlet individually to the rest of the trap. Okay, so now that we're on to drawing our outlet, we need to come up with the dimensions. We don't come up with them. I mean, they're given to us by Iplex, but they've kind of left a little bit out. So we have to do a little bit of maths, not that much. Bit of simple subtraction. But yeah, so just drawing in some reference lines here. So this will be the center of the outlet. And the other reference line that I've drawn will be the back face of the outlet there. So again, we're going to need to do a sweep. And I actually want to do an angle, or an arc, I should say. So I've drawn out at a 45-degree angle. I don't actually have to figure out that dimension. And I just draw it until I hit that reference line, and away I go. So you can see this is our outlet. We're done. So the next thing we need to do is pop a circle on, and again, 110 mil or 55 radius. And look at that. Fantastic. So, of course, as always, no one likes an angry hydraulic designer. Actually, nobody likes hydraulic designers. That's probably true as well. Nobody likes an angry hydraulics designer, so we better put that socket on. So we've got our reference plane there. And again, it's a circle, a line and lock, 55 mil plus 3 mil for the wall thickness, total of 58, and that's our socket. Come back into the front view, and you can see there's our extrusion. Now, it always looks like that because by default Revit draws a 250 millimeter extrusion. So we'll just align and lock that to our planes. Remember, our socket is like 45 millimeters in depth. Although in this instance, did that say 51? I can't remember. It was a long time ago that I drew this. Anyway, so there's our outlet. And again, same deal. We're going to make everything look like it's one part by using the join tool. And that's our outlet. So I'm going to save this, and I'm going to save this as simply Family 3. Don't save it as Family 3. So it's a disconnector trap outlet. Fantastic. Makes plenty of sense. I do recommend naming things a little bit better than that. I normally use the ANZRS format, ANZRS, and that's based on functional type, the subtype, the manufacturer, and a descriptor. So you can see, well, we've almost got a floor waist there. So let's just drop this down. We'll align and lock that outlet to the correct height. And you can see there, if we jump back into 3D, that's our four-way riser and disconnected trap, or 100mm floor waste gully. So what I'm going to do is I'm just going to rotate the four-way riser manually within the model. Make sure you pick the right center point. And I'm just going to rotate it out. Now, I'm going to put on an angular dimension between the reference plane and the reference plane that is in the nested family. Now we apply a parameter to that. And once we've done that, we can actually control the angle, the direction of the four-way riser. So again, we're going to do that for the outlet. So we need to pick the right location, put a little bit of a rotate on it, and then we pop that angular dimension in. And it really is that simple. So we apply our parameter. So this one's going to be outlet rotation. The previous one was four-way riser rotation. And both of these are instance parameters, which means you can change this angle for every single instance of this particular family in your project. And you can see there, like as we change the angle, you can see that four-way riser moving. And again, the same thing for the outlet. All of a sudden, you've gone from having some shoddy floor waste that you've cobbled together from out-of-the-box Revit families to having a brilliant, accurate one-to-one Iplex floor waste gully. So once you've tested the flexing of all the parts in the floor waste, the last thing that we need to do is add pipe connectors. So the way that this family is built is it's designed to have a pipe connector come out of the top. Originally, I used to have the four-way riser extend right up to the slab, so you could drop the trap by up to 1 meter. But that's not actually technically correct. So you'd actually have the pipe coming out through the slab, and then that would drop 1 meter before it hit the four-way riser. So that's why there's that pipe connector on the top. So now we're going to drop the pipe connectors on the inlets. Well, we change this one to 50, this particular one. We want to set it to sanitary, and we want to make sure that we have the allow slope adjustments ticked. Those last three, we set them to 40. Of course, they're in. Allow slope adjustment is ticked. And the last one, 100 mil. And again, allow slope adjustment is ticked. Well, this one's out though. So yeah, don't forget to tick that, because if you don't tick that allow slope adjustment, that will cause you a lot of grief when you're trying to model. So Revit will only let you model at the same angle that the connector is at, which is straight up and down or 90 degrees. So I'm just going to save this file. And this particular family, so the other two families that are nested, they're pipe fittings. This one is a plumbing fixture. Now there's a few reasons for that, but the main reason behind it all is that councils, local authorities, they will usually count a floor waste gully as a fixture. So when you go through and you do all of your schedules to put on your drawings and you want to schedule out the plumbing fixtures, so Brisbane City Council, Gold Coast City Council, for example, require a fixture schedule. The floor waste gullies will show up and they show up as a single fixture. And I mean, now it's the part you've all been waiting for. Let's actually see this guy in action. So I'm just creating a new project. I'm basing it on the out of the box plumbing template to show that there's no funny business. Going to drop the floor waste in. Now it's not showing up because the view range is not going low enough. So remember, the floor waste goes below the floor. So there it is there. And now let's just connect some basic pipe work. So we're drawing at 1 and 60, and it's a no-go. The problem there is that I didn't choose the right diameter of pipe work. So now there you go. You can see that we're connected at 1 and 60. Jump into 3D, just flick that over to fine mode. And there you go. Now, the one thing is that you will see a little bit of a gap, but otherwise it all connects, it all works. And there you have it. You have a fantastic working floor waste gully.